Hello everyone, and welcome to the Timeit module lecture. So in this lecture we'll learn about timing your code and how to use the Timeit module to do that. So first thing you're going to want to do is check out this Jupyter notebook. We go over two methods, importing Timeit, which is how you would use the module in standard Python, and then we'll also look at a bit of magic functions that we can use in Jupyter with IPython. Okay. So let's go ahead and hop over to the live code. So the first thing you're going to need to do is import Timeit. Alright, so now that it's imported, what we're going to do is use Timeit to time various methods of creating the string that looks like this. So I want to create a string that looks 0-1-2-3- all the way to -99. So we're going to use a bunch of different methods to make that string. So one way we can do it is by saying join, dot join the string n for n in range 100. Okay, so that's exactly the kind of string we want. So what's this doing here? It's saying for every n in that range, 0 to 99, go ahead and convert that integer to a string, and then join it with a dash in between. Alright, so what we're going to do is now time this method. So now that we've imported the Timeit module, what we're going to do is say Timeit. And what you do is you pass your entire expression, whatever it happens to be, as a string here. And then the second argument is the number of times you want to run this. So I'm going to run it, let's say 10,000 times. If you don't do enough times, it'll be too fast to get an accurate comparison to different methods. Okay, so this method took about 0.248 seconds. And it's going to be different depending on how fast your computer is. So don't be worried if you don't get numbers exactly like mine. Now let's try doing a different method with list comprehension. So we basically did a for loop in essence here. And what we're going to do now is try list comprehension. So I'm going to say try joining here and add the brackets to make it a list comprehension. Let's go ahead and run this. Let's actually run it. Let's run this as a separate line so we can keep everything in sight. So we'll run it as a list comprehension here. And notice it was a little bit faster. And what we're going to do now, finally, is try using the map function. So what I'm going to do is say .join. I'm going to map the string function to every number from the range 0 up to 100. And then what we're going to do is pass that in as a string itself into Timeit. Timeit. And the number of times I want this to run again, number equals 10,000 times. Alright, now notice by far map is the most efficient way. So we can see that there's a significant time difference using the map function. So this is good to know, you should keep it in mind. But this is the way you would generally use Timeit in your own code if you weren't working in a Jupyter notebook. Now if you're working in a Jupyter notebook, the best way to do this is using Python's built-in magic. So we discussed built-in magic a little bit when we were going over Jupyter notebooks. But basically, built-in magic is defined by a percentage sign. And it basically has Timeit built in. So what I'm going to say is Timeit, and then just copy this method, and you don't need to pass them as strings anymore. And the interesting thing about Timeit is what it's going to do is it's going to perform the same code in that line a certain number of times. So it's going to do it through a couple loops. So in this case, it did it through 10,000 loops, and then it'll report back the best of 3. So in this case, the best was 28.9 microseconds per loop. Now remember, in this case, with Timeit, it's telling you the total time it took to perform all 10,000 of those. Which makes sense if you see, 10,000 times whatever this number, or this number divided by 10,000, and you have microseconds. All right, moving along, let's go ahead and use the magic function to test out the rest of these. So magic, percentage sign, Timeit, and in this case, I'm going to check the list comprehension. And then what's really nice about using this magic function is that it gives you a better idea of how long it's actually taking to perform, on average, the command. With this normal Timeit method, you have to kind of decide a large number of times to perform it, and you don't get a good idea of how long each individual time is going. And if you're just doing one here on the number, you probably won't get an accurate average, unlike Timeit here. Now notice, this is where the magic function is really great. Here when we ran it with map, since map was so much faster than the other methods, Jupyter or IPython ran it 100,000 times through 100,000 loops instead of through just 10,000. So you'll notice if something takes a really long time to run, the Jupyter or IPython may just run it 3 times if it takes many seconds to run. If it's very fast, it will run it more times to get a better average. But basically we arrive at the same conclusion. The map function was the fastest method of them all. And like I said before, IPython will limit the amount of real time it will spend on its Timeit procedure. So if you're running 100,000 loops that would have taken 10 minutes, IPython's automatically going to reduce the number of loops to something more reasonable, like 100 or 1,000, depending on how long it actually takes. Okay, so as always, there's the Jupyter Notebook with more comprehensive breakdown of what's going on, and you can check out the documentation here for the Timeit library. Go ahead and check out that link, and you can learn about a couple more methods and timers to use. All right, that's it as far as using Timeit to time your code. I will see you at the next lecture.